All right, let's talk about my favorite, exponential functions. Before we get into exponential functions, let's do just a little bit of review. First, remember that our domain is all values of x where a function is defined. So our domain is our x values. It's what you can plug into the function in the input and get an answer. Sometimes we will not be able to plug values in to our function, and that's what we mean by defined versus undefined. Our range is all values of y that a function achieves. It's the values that come out of a function, the output when the x values are plugged in. Remember back in the day that f of x replaced y in our equations when we moved to function notation. And additionally, remember that we are going to concentrate on our real numbers, not the imaginary numbers. Our interval notation is used to identify all values a variable can be for a function or inequality. It's in the form parentheses, smallest number, comma, largest number, close parenthesis. And the parentheses can also be brackets, or you could have a mixture of the two, but it always goes smallest to largest. Parentheses are when you cannot actually hit the value or use that boundary number. Your positive and negative infinities will always have parentheses, whereas brackets are used when you can actually reach that number. You can actually plug it in to your function. Exponential functions. These are in the form f of x equal to b to the x, where b is a positive real number and b does not equal 1. B stands for our base. Okay, so b is our base, and then x is our x in the exponent. Okay. We don't do b equal to 1 because it's boring. 1 to anything is 1. Just different base to make things interesting. You know you have an exponential function when the variable is in the exponent. That's where exponential gets its name. Our natural base is e. This is why we ask you to not use e as one of your variables. It is an irrational constant like pi. Pi is 3.1415, blah, blah, blah. E is 2.71, blah, 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 blah. Okay, but it is our natural base. And the natural exponential function is f of x equal to e to the x. This is used a lot in nature. That's why it's our natural function. Looking at some examples, says evaluate the following exponential equations at the given values, then write the ordered pairs. So what they are saying is that we have an exponential because our variable's in the exponent. And they want us to plug this value in whenever we see an x. So we need to find f of 3, which means in our function, we're going to have 5 to the 3 instead of x minus 1. Start working on the arithmetic. 3 minus 1 gets us 2. So 5 squared. And remember, 5 squared is not 5 times 2. It's 5 times 5, which gets us 25. Our x value that we plugged in was 3. And the y value is what we got out, the f of 3, which is 25. So our ordered pair is 3, 25. Remember, x always comes first, y comes second in your ordered pair. Looking at your second example, we're asked to find g of 1 in this exponential. Again, we know it's an exponential because we have our x in the exponent. By plugging in, we're going to have 5 times 2, and then we're in the exponent. 3 times 1 minus 4. But notice that that 4 that I just wrote shouldn't be down here like this. Even though we plugged in the 1, that 4 is still up in the exponent. Don't try to move stuff around. If it's in the exponent, keep it in the exponent. We are not going to be able to multiply the 5 and the 2 because the 2 is being taken care of with an exponent. So we have 5 to the times 2 to the 3 minus 4. This gets us 5 times 2 to the negative 1. When you do this one in your calculator and convert it back to a fraction, you should get 5 halves. And that is because that 2 to the negative 1 becomes 1 all over 2. So what ordered pair did we just find? We plugged 1 in for x, so our x value is 1, and we got out 5 halves as our y value. So our ordered pair, x comma y, is 1 comma 5 halves. This time they want us to do the same thing, but we're going to be using the natural exponential, the e to the x. So this time when we're finding f of 1, we're going to have e to the 1. Now, if you are on a TI 83 or 84, to find your E button, you are going to press your second button on the left-hand side, normally blue or yellow. Press that button, and then on the left-hand side, third from the bottom, you should see an LN button. So go ahead and press the second button, and the LN, the e to the x is hanging out above the LN. And then you're going to have E showing up on your home screen. Go ahead and put 1 on the inside and hit enter. If you are at desmos.com/scientific, you're going to press function, the FUNC option on the left-hand side. It's a FUNC tab, and find your E on the right-hand side. E to the first gets us 2.71828, so forth and so on. We need to round to the nearest hundredth, which is 2 decimal places. So if we look at the third decimal place, 8 is enough to round us up, because remember, 5 and up, round up. 4 and lower, stay low. So we get 2.72. To write my ordered pair, my x value comes first, and we plugged in 1. My y value, which came second, was 2.72. So my ordered pair is 1 comma 2.72. Let's do the problem again. This time we're going to plug in -3. So f of -3 gets us e to the -3. you want to rewrite this with positive exponents, you can. It would become 1 all over e to the positive 3. Or you can plug it directly into your calculator, because we're going to get a decimal anyway. You should be getting 0.04978 ... so forth and so on. So if we are rounding to the nearest hundredth, look at the third place. 9 is 5 or more, which rounds us up, and we get an answer of 0.05. The ordered pair we just found was -3, because we plugged in the x of -3, and our y value is 0.05.